problem 3. Suppose in triangle ABC, C is equal to 90 degrees. Angle A is 43 degrees. Side C is 80 centimeters. Find side B and answer with significant digits. So the biggest problem I've seen in the past on these is not putting your sides in the correct spot. Remember, side B is across from angle B. That's what we're trying to find. So from this angle, the 80 represents which side if you're thinking about so. Yep, that's your hypotenuse. B is the adjacent. So what trig function involves adjacent and hypotenuse? So the cosine of 43 degrees equals B over 80. So then we have to multiply over our 80. And use one of these calculators because I don't have any others today. Make sure you are in degree mode. And so we have a cosine of 43. So we get 58.5083. But it said significant digits. So if I'm looking, 43 is 2, but 80 is how many significant digits? 1. So this would round all the way up to 60, just because I said go to significant digits. Yeah, if you found angle B and did sine, should have gotten the same thing.
I was really confused on how I got the sine.
Did we do okay on number 4?
I have a question. Can you do the law of sines even if it's 90?
Yes. Number 5. A person standing on top of a 13-foot high sand pile wishes to estimate the width of the pile. So we have a pile. Okay, the height of it is 13. We're trying to find how wide it is. He locates 2 rocks on the ground at the base of the sand pile. The rocks are on opposite sides of the sand pile. The angles of depression from the top of the pile. Angle of depression, you have to have a horizontal line. So it's saying from the horizontal line down, the angles are 19 degrees and 25 degrees. Now those are not inside my triangle. So how could I get an angle inside my triangle? Okay, you have 2 options. Alternate interior, this one down here would be 19 if you did that. The other option would be to do what? Yep, 90 minus 19 will be 71. So either option works. This one would be 65, or you could, if you went down here, that's 25. So lots of options there for our angles. Now, we are going to have to treat this as 2 separate triangles. So here's my right angle. We are finding the bottom here. So if I use the 65, this is opposite and that's adjacent, which is what trig function? So tangent of 65 degrees equals the opposite side x over the adjacent side 13. Multiply over the 13. And I don't want to round too much here. So 27.8786. So then if I look at my other right triangle, I could say the tangent of 71 degrees equals y over 13. Multiply the 13. So 13 tangent of 71 is 37.7547. And then what do I need to do to those? Add them together. So we get 65.6333, but I said significant digits. So we were given 2 in the problem, so that would be 66 feet. Number 9. Find the radian measure of a central angle cutting off an arc length of 6 inches. So arc length is what variable?
Yes.
So S is 6 inches. In a circle with a radius, so R is 2 inches. If we're looking for the radian measure, we're looking for theta. So what I encourage you to do on these problems is write it out just like this so we know what variables we have. And then if you're looking at your formula sheet, what formula involves these variables?
S equals R theta.
So I always ask that you write down your formula so I kind of have something to base your answer off of. So our S was 6, R was 2, theta. So if we divide, theta is going to be 3. And we do not need a unit there. If we had included units in our problems, 6 inches divided by 2 inches, those inches cancel. And that's when we're in radians, if there are no other units left.
Can we still say like rad?
Yes, that would be fine. Just don't throw a degree symbol on there. Remember, on these formulas, the number you put in has to be radians and the number you get out is always radians. If I asked you to turn that into degrees, what would you do?
Times pi or 180 over pi.
180 over pi.
Next.
Next one. So point P moves with an angular velocity. What variable is angular velocity?
Omega.
So that's 10 radians per second. On a circle with a radius, so r, of 3 feet. The distance traveled. If you're talking about the distance on the outside of the circle, what variable is that? And our time is 4 minutes. That's our first problem. What's wrong with it?
No.
Yes, that's minutes, but my rate is in seconds. So I have to change one of them. Doesn't matter which, but they have to match. So if I just wanted to change 4 minutes into seconds, yep, 60 seconds in a minute. So 4 times 60 is 240. So now if we're looking for S, our formulas, we have V equals R omega. We have, oh, sorry, I'm looking for S formulas first. Let's start there. S equals R theta, but we don't have theta. We can do V equals S over T, but we don't have V. So that tells me I'm going to have to use more than one formula.
S equals R.
Okay. So you have 2 options. We need another formula to get either theta or V. So we can either do V equals R omega, or we can do omega equals theta over T. It's not going to matter. Which one do you want to use?
S
It's about you.
S equals R theta. Is that not a real
S-
formula? Was that where I screwed up? Did I
Yeah,
make
we made
up
up a formula. So you want to find V? Is that what you said?
I said that.
Okay. So let's use this one then. So omega equals theta over T. So we know the omega is 10 radians per second equals theta over 240 seconds. So theta is 2,400. Then we can do S equals R theta. So our R is 3 feet, theta is 2,400. So if we multiply, we get 7,200. And this was feet times radians. So radians are the extra unit. If you don't have a unit, you use it. If you have too many, it goes away.
I seriously could not figure out
how you
I
calculate
didn't
it.
even use that formula. I don't know how I got this so wrong.
Fine. Number 12. A lawn sprinkler is located at the corner of the yard. The sprinkler is set to rotate through 90 degrees. So what variable does that represent?
Okay. Theta, you know, the circle, the one that was in out.
And projects water out to 53 feet. So it's shooting water out like this. What variable is that?
Arc.
Mm,
Radius?
the 53 feet is your radius. What is the area of the yard water? So area is 1/2 r squared theta. So we're all set, except there is a problem. What is it?
You're not shooting out water by half. You're shooting it by a
Theta, in any problem, if you want to use the formula, your angle has to be in radians. So instead of 90 degrees, how many radians is that? Pi over 2. So if I plug in my pi over 2. So different possible answers depending on how much you multiply it out. This is like 2,809 pi over 4. I didn't specify significant digits. If you divided that by 4, you could have 702.25 pi, or if you multiplied out the pi, could have said 2,206.18. But our unit area is always squared, so square feet.
Because I honestly, like, it's not gonna, I don't even know how I got the correct answer. Hear me out.
Because you did pi.
My ideology was it's only shooting through a fourth of the yard. I don't know how I got the correct answer.
You kind of got lucky.
Okay.
Because the angle was 90 degrees, which is a fourth, so that's kind of why it worked. But you would want to be careful if I threw a different angle.
So Tyler did yell at me for this one, and he said, "How did you do that?" And I said, "I explained my theory, and Tyler didn't believe me."
It works because you had a nice angle.
Okay.
Don't give me like that.
No, you were right.
Because
You were right.
Okay, so problem 15. We have indicate the quadrants in which the terminal side of theta must lie in order that cosine theta is positive. So if cosine theta is positive, in which of those quadrants is cosine positive?
One.
Okay. And tangent is negative. When is tangent negative? So the only one that works is quadrant 4. Okay, if I ask you to find this, the work I would expect, quadrant, reference angle. What quadrant is 225 in? Quadrant 3.
My bad, sorry.
And then our theta is 45. 225 minus 180. In quadrant 3, is sign positive or negative? Negative, and then the sign of 45 is negative radical 2 over 2. The secant of 5 pi over 6. What quadrant is that? Quadrant 2 because it's less than pi. Reference angle with radians, all you have to do is pi over the denominator. Pi over 6 is like what degree? 30 degrees. Okay. Secant is a reciprocal of cosine. In quadrant 2, is cosine positive or negative? Negative. And then the cosine of 30 is radical 3 over 2, so if we flip it, 2 over radical 3 gives us negative 2 radical 3 over 3. Problem 19. So we have 4 cosine negative 3 pi over 4. Okay, usually if it was a negative, we try to rewrite the problem first. How would we make that a positive? Add 2 pi. If you don't like radians, you can change it to degrees and add 360. But all right, 2 pi is like 8 over 4, so that would be 5 pi over 4. All right, what quadrant is 5 pi over 4 in? 3 because the top is bigger than the bottom, so it's bigger than the 1. So quadrant 3. Reference angle is pi over 4. The 4 on the outside is just staying. And quadrant 3 is cosine positive or negative? Negative. Okay, what is the cosine of pi over 4? So if I take that times 4, you give me negative 2 radical 2. Problem 20. I want the exact value of cosine 5 pi over 12. First of all, is pi over 12 an angle we know? Okay, so to make it easier to think about, what do we need to do? Change it to degrees. How do we do that, everybody?
Pi over 180.
Other way.
Yeah, my bad. I'm sorry.
Quite all right.
I did it earlier.
Okay, so 5 times 180 divided by 12, what does that get me? Okay, not an angle we know, but we could break it up using ones we do know. How did you write it?
45 plus 30.
Okay. So, if I am adding these, this is the point where you would go to your formula sheet. Because we know we can't just distribute the cosine. We had a whole several lessons on that. So, this is the cosine of A plus B. So, the formula is cosine of A, cosine of B, minus sine of A, sine of B. Cosine of 45, cosine of 30, minus sine of 45, sine of 30. So if you multiply numbers under the radicals get multiplied together, so that's radical 6 over 2 times 2 is 4, minus radical 2 times 1 is radical 2 over 4. You could write it like this, and you're welcome to put them together into one fraction. Either answer is okay, but because I said exact, you have to leave them like that. Okay, you can't change it to decimals. Any questions there? Alright. 21. Simplify. Cosecant of x over sine x minus cotangent x over tangent x. So this was kind of like the beginning of our proofs before we had a full-on proof where we knew what it was supposed to equal. We were starting with something like this and practicing manipulating them. Our general strategy was to change sines and cosines. So cosecant would be over sine x. If you want that as fraction, that's just like sine over 1. Cotangent is, and remember, those are not on your formula sheet. Tangent is how do we divide fractions? multiply the tops. 1 times 1 is 1. Sine x times sine x is sine squared x. Minus cosine times cosine is cosine squared x over sine squared x. But we're not really done. These have a common denominator, so now we can put them together. Okay, so our Pythagorean identities, we know sine squared plus cosine squared equals 1. So 1 minus cosine squared is sine squared. And sine squared divided by sine squared is 1. Make sure you are using proper notation. That means you have to include your x's throughout the problem. You can't just throw it on the final answer. I will take off some if you're not using those. All right, are there any other questions over the first half of this? Okay, so second half we will go over tomorrow along with any additional questions that you guys have. So you have time right now if you need to work and finish up any other.